Hello everyone. In this video, we are going to learn about chapter 2, which is polynomials. First, let us look into some of the basics that we need to know before we get into this chapter. So, constants, variables, and terms. So, any number, like it can be 5 or -2, or it can also be in fraction, like 2 by 3 or -5 by 2. It can also be in irrational, which is root 2, root 3, and so on. So these all come under constants. Uh, Alphabets which have been given, which can take any value depending upon the context, they are called variables, which is x, y, a, b, and so on. And the terms is a very important idea that we need to understand. Terms are distinguished only by plus and minus, like addition and subtraction. For example, when we say x plus 5, there are two terms. One is x, one is 5. But when we say 2x minus 3, 2 and x together is a single term and 3 is another term. So because 2 and x are in product like multiplication, we don't call it as two terms, it will be a single term. The same holds good for division as well. When we say 5 by 2 minus x, this 5 by 2 is a single term and x is a separate term. So the terms are distinguished only by plus and minus. For example, when we say 2xy minus 1, this doesn't have four terms, it has only two terms, which means 2xy is a single term and 1 is another term. So these are all some of the basics that we need to know. And with these ideas, when we combine all of this in some form or the other, then that expression, that algebraic expression, is called polynomials. For example, the general form of a polynomial, especially a quadratic polynomial, is ax square plus bx plus c. Here a, b, c are constants about which I just told you, and x is the variable, and there are three terms 1, 2, and 3. So, but a polynomial need not have the highest power as 2. It can also have 3. For example, ax cube plus bx square plus cx plus d. It can also be like this. And it's very important to note here that some of these terms may have lesser number of terms. For example, in this example, the x term need not exist or the x square term need not exist. It depends upon the question. So now, having understood all these basics, like basically polynomial is a combination of constants and variables and terms, and they can have any power for the variable x, and that highest power which is existing in an equation is called the degree of a polynomial, which is the next concept, as you can see. So the highest power of x in p of x, and we represent a polynomial as p of x because it's a polynomial containing x. If the polynomial contains y, then it is p of y, and so on. And in this case, we can see that there are two x terms. Here the power of x is 1, whereas here the power of x is 2, and 2 is the highest. So therefore we call the degree of this particular polynomial is 2. So degree is basically, when we have variables, the highest power of x is called degree of the polynomial. Now, it's important to understand the classification of polynomials, like the types. Depending on the number of terms, we can classify them as monomial or binomial or trinomial. So here the idea is monomial basically means it will have only one term. For example, 5x or minus 2y. These all contain only one term. Binomial, polynomials which contain two terms. For example, 2x minus 3 by 5 or x plus 2. So these are all containing two terms. And trinomial is basically containing three terms. For example, x square minus 3x plus 5. This is based on the number of terms that are present in the polynomial. There is another way we can classify, which is based on the degree of the polynomial. That is the next concept. So when we say linear, then the degree of the polynomial is 1. For example, 3x plus 5. So as you can see, there is variable x and its power is 1. Another example is 2y minus 5. Here also the power of y is 1. Quadratic. Here the highest power of the variable will be 2, which means 2x square minus 3x plus 5. This is an example. As you can see, the highest power, that is the degree, is 2, then it's called quadratic. Obviously, cubic is highest power is 3. When I say that, it can be x cube minus 2x square minus 5 by 2x plus 9, something like this. Or it can still have the highest power of as 3 and not have a few terms in between, like this. In this equation, you can see there is 3 2, but there is no x power 1, which can still exist. So these are all the things. And biquadratic means the highest power of x will be 4. For example, x power 4 minus 5x cube minus 2x square plus 3x minus 2 equal to 0. Something like this. I'm just giving random examples. So these are all the types of polynomials based on the degree. What all I have said so far is important from a 1 mark question point of view. So that brings me to the next one, called zero of a polynomial. So what is meant by zero of a polynomial? So basically, let me take a very simple example as x minus 5. Now, for what value of x will this give the answer 0? Yeah, it is 5. So when we put the value of x as 5, then 5 minus 5, we will get 0. So 0 of a polynomial is basically the root of a polynomial, which also means the value of x that we need to give in order to get the answer as 0. This can also be obtained in a different way. That is x minus 5 equal to 0. We equate it initially to 0. And then when we separate the value of x, this minus 5 goes to the other side and becomes plus 5. That's also another way in which we can find the 0 of a polynomial. And I have just given an example of a linear polynomial. That is a very simple example. But when it comes to quadratic polynomial or cubic polynomial, we have different strategies to find the 0 of a polynomial. Just to summarize, 0 of a polynomial is a value which, when substituted in the place of the variable, will give the answer as 0. Another example, when we take 2y minus 5 equals 0, then when we equate this, that is minus 5 goes to the other side and becomes plus 5, and then y becomes 5 by 2. This y equals 5 by 2 is called 0 of this polynomial, because when we substitute this 5 by 2 in the place of y, we will be getting 0. Since we get 0, it is called 0 of a polynomial. The next concept is geometric meaning of zeros of a polynomial. Like, how do we visualize them in the graph or in the Cartesian plane? So for each, I've taken one example for linear, one for quadratic, and one for cubic. When we take example for linear polynomial, as we can see here, the example which I've taken is y equals 2x plus 3. Basically, 2x plus 3 is the polynomial, and I have named that polynomial function as y. It can also be written as p of x. So now we have taken a linear polynomial. Can you tell me why it is called linear? Yeah, as we can see, the highest power of x is 1. That's why we call it as a linear polynomial. Now we are trying to draw the graph for this. What happens is we have to keep giving random values for x, and then we will get values for y. We have learned this in grade 9. So some examples are when we take the value of x as minus 2 as given in the tabular form, we will be getting the answer as minus 1, as you can see here. That is written here in the tabular form. So now when I give the value of x as minus 2, it's coming as minus 1. Likewise, when I give the value of x as 2, then I'm getting 7, which is also written over here. So once we get two such values, we are ready to plot them on the graph. As you can see from the tabular form, minus 2 comma 1 is 1 point, like this, x and y values, and 2 comma 7 is another value. So minus 2 is here and minus 1 is here, which means this is the point, and 2 7, 2 is here and 7 is here. So this is the point. And we can try to join these two using, when we try to join these two using a line, then we get a straight line. When we join these two, we'll be getting a straight line like this. So since when we join, and even if we plot one more point, still we will be getting a straight line. So that is the concept. Like when we take some other random value of x and we plot, all of them will lie on the same straight line. And this is the concept. This is the geometric representation of linear polynomial, which means we'll be getting a straight line when we use a ruler. And we'll use arrow marks to show that it's a line and not line segment. So when we try to draw a linear polynomial or plot a linear polynomial, we'll always get a straight line. This is something we need to understand. Now, what about quadratic polynomial? When I try to draw a quadratic polynomial, then what will I be getting? That is something we'll be learning next. For example, we have taken x square minus 3x minus 4. So when we take this polynomial, again giving some random values for x and then getting the value of y. As you can see, when we give the value of minus 2, for example, minus 2 the whole square, minus 3 times minus 2 minus 4. In the question, wherever there is x, we are substituting minus 2. Then this becomes plus 4 and this becomes plus 6, and then minus 4. Now minus 4 plus 4 get cancelled, we get the value of 6. So likewise, we have taken random values, minus 2, minus 1, 0, 1, 2, 3, 4, 5. And we have come up with some values for y as well, the function y as well. When we try to draw these points on the graph, then let us see what we are getting. So when we try to draw these points on the graph, as you can see, minus 2 comma 6 is somewhere here. And minus 1 comma 0 is somewhere here. And 0 comma minus 4 is here. Isn't it? Yeah. 1 comma minus 6 is here. And 2 comma minus 6 is here. And then 3 comma minus 4 is here. And 4 comma 0 is here. And 5 comma 6 is somewhere over here. Now when we try to join all of this, we will get a curve like this instead of a straight line as we got in linear case. Here it is quadratic, so we'll be getting a curve like this. And this curve is called a parabola. And this is an open upward parabola. And sometimes we may also get a parabola like this, which is open downwards or open leftwards, open rightwards, and so on. About these, we'll be learning in detail in grade 11. But a parabola is basically something that is U-shaped, and most of the quadratic equations will give us a parabola like this. Now, it is very important to note here that as we can see here, this parabola joins or cuts the x-axis at two distinct points. That is why we call it as a quadratic equation. So the number of places where it will cross the x-axis will give the number of zeros. For example, in case of a linear case, like the previous case, we'll be getting a straight line and it will join the x-axis at only one point, which means it has 1 0. Here in quadratic case, it cuts the x-axis at 2 points, which means it has two zeros. Now, I would like to bring our attention to a very important case where we need to understand that not all quadratic equations will always have two zeros. For example, there are quadratic equations which may have one zero or no zeros as well, which means we have to look at the definition of number of zeros a little differently, which means when we say quadratic, we call it as quadratic because the highest power is 2, as you can see, which means at most it will have two zeros, which means it can have two zeros or one zero or no zeros as well. For example, when we take the quadratic equation x square minus 4x plus 4 and repeat a similar tabular column for this, like giving random values for the x and getting the values of y, and then when we try to plot it on the graph, we will be able to get a graph but with only one zero, which means the graph will meet something like this. It will only touch the x-axis at only one point. So here what I'm trying to say is a quadratic equation need not always touch the x-axis at 2 points and have two zeros. Instead, it may also touch the x-axis at one point and have one zero, or it need not touch and still have zero zeros, like there is no zeros. For example, when we take the case of x square plus 1 as an equation, this will have no zeros, and an equation like this will have one zero, whereas the question has two zeros. So this implies, but all the three are quadratic equations, that is they have the highest power of x as 2, but still some of them will have the maximum of two zeros, some of them will have only one zero, some of them will have no zeros, and we'll be able to find these out by plotting them on the graph as to how many zeros they have. So that brings me to the next one, which is cubic polynomial. As you can see here, we have given random values for x, and we have got the values of y. And one is minus 2 comma 0, which is basically this point on the graph. Yeah. And minus 1 comma 3, which is this point. 0 comma 0 is this point, which is the origin. 1 comma minus 3 is this point, and 2 comma 0 is this point. As you can see here, we are getting more of a curve like this when we join these. So for cubic polynomials, we'll be getting a curve which is a little more complex than a simple parabola. That is something we need to understand. And we should also know that just because it is cubic or the power is 3, it doesn't mean it should always have three zeros. For example, in this case, it cuts the x-axis at 3 points, as you can see, 1, 2, and 3. But it need not always cut the x-axis at 3 points. It may still cut it at 2 points and still be a cubic polynomial, which means for a cubic polynomial, the highest power is 3. That means it can have three zeros, or it may have two zeros, or one zero, or no zeros at all. And that we will be able to identify from the graph depending on how many times it cuts the x-axis. So, having said all of this, it's very important to understand that the number of times a particular graph cuts the x-axis will give the number of zeros, but not necessarily give information about the type of polynomial it is, because it may have, for example, two zeros, but it can still be a cubic polynomial. This we'll be learning in the next question. So this is the first type of question that we're learning in this chapter. Find the number of zeros of p of x. And as I have mentioned, with two stars, you can see it is of medium importance. And also it's important from 1 mark point of view. And from the first graph, how many times does it cross the x-axis? You can see 1, 2, 3, and 4. This means the number of zeros is 4, but it need not be a biquadratic polynomial, like a polynomial having the degree as 4. It may still have a degree of 5 and then have four zeros, as I said in the example of quadratic polynomials. Here it doesn't cut the x-axis at all, so it has no zeros. that is zero zeros. And again, it can be a quadratic polynomial, a linear polynomial, and so on. So this is about our first exercise.